Okay, students, if you'll get out your notes, we'll do lesson 2. You might want to pause me until you're ready. Okay, here we go. Outcomes are objectives. You're going to identify and describe organic compounds. You're going to name and draw structural, condensed structural, and line diagrams. You will learn about saturation, or what saturated means, and we're only going to deal with carbon chains up to 10 carbons long. Okay, so we're going to start with naming. Nomenclature is just a fancy word for naming. We're going to learn how to name compounds. The guys that create the rules for these names work for IUPAC, the International Union of Pure and Applied Chemistry. Lots of times I'll see a student working away at his desk and he'll say, "This is a dumb name for this compound. Who came up with this name?" Well, these guys did. And if you want to change these rules, then you'll have to apply to be a member of IUPAC, and then you can have some say. Otherwise, you're going to have to deal with these rules. Okay, here we go. All carbons have 4 bonds around them, and because they have 4 bonds, they can make millions of combinations. So, like, there's 1 carbon. There's 2 carbons. But because there's 4 bonds, you can just keep linking them together and just keep going, and these can be really, really long chains. But we're only going to deal with 10 carbon chains. Now, with the molecules we deal with, there's going to be parents and branches. So let's talk about those. Okay, let's meet the parents. Okay, so how are we going to name parents? It's the first thing we need to talk about, naming the parent. Okay, the parent is the longest continuous chain. Okay, so you just find the longest chain, and I'll show you that in just a second, and that's the parent. It has to be a continuous chain though, and you'll see what that means as we go through this. And we have to use prefixes to name these things. So here's some prefixes. Meth in chemistry means 1. Eth means 2. Prop means 3. Bute means 4. And then these ones are numerical. Pent, like pentagon, is 5. Hex, hept, oct, non, dec. All right. And then there's suffixes as well. If the molecule has just single bonds, the suffix is ane. So watch this. There's 2 carbons. Okay, 2 carbons in a chain. Let's give it a name. 2 carbons. The prefix is eth, so we'll put eth down. And we look at the molecule, and there is just single bonds, no double bonds in there. And so therefore the suffix is ane. There, ethane. Easy. That's the name of it, ethane. Next one, 4 carbons in a chain. That's bute. And there are just single bonds again. And so that's butane. So butane is found in those Bic lighters, right? That's butane. That's what it is. 4 carbons strung together with hydrogens all the way around. Remember, we don't have to write the hydrogens. We know they're there. What would that one be? Well, we count it 1, 2, 3, 4, 5, 6, 7, 8. 8 carbons. That's oct. Single bonds. That's octane. This is the basic molecule in gasoline. Octane. Alright, now we're not dealing with double bonds or triple bonds today. If we were, it would be octene or octine. But we'll get to that in another lesson. Okay, next. Now we got to name branches. Okay, same thing. When we're naming branches, we need to have branches. Okay, so didn't know where I was going there. Okay, so when we're naming branches, you have to find the longest continuous chain, and that's the parent. So there's our longest chain. 1, 2, 3, 4. We could have gone this way. 1, 2, 3, 4. But this makes it easy, and it'll come out the same either way. So there's our parent. And we know what the parent's name is. It's 4 carbons. It's single bonds. The parent is butane. Now, these 2 carbons here are branches. If this is the parent, then these are the branches. So let's just show those. Those are branches. Now, how do we name these branches? Well, each branch has to have a name, of course. Here's how you do it. You have to have a prefix again. The prefix indicates the number of carbons in the branch. So again, meth is 1, eth is 2, prop is 3. And the suffix YL tells you it's a branch. So watch this. In that branch, there is 1 carbon, so its name is meth, and we know it's a branch, so it's methyl. Same thing with the other one. There's 1 carbon in that branch, it's methyl. Okay, a 3 carbon branch would be called what? I'll give you a second to think about it. You're right. 3 carbons would be prop. Oh, it's a propyl branch. All right. Now, if there's more than one of a certain type of branch, there's another prefix used. It's a prefix in front of a prefix, which is kind of weird. Blame IUPAC if you don't like it. Or if you want to change it, become a member of IUPAC. But it's a prefix in front of a prefix. So watch this. We have 2 methyls. So we use another prefix here. There's a prefix for 2, di. So we would call this dimethyl because there's 2 methyls. All right. Now, I say here every branch gets a number. We'll talk about that a little later. Branches are always listed in alphabetical order. You'll see that coming up. Okay, let's move on. Okay, now, steps for naming compounds. All right, so look at this compound. Now, we got to give that a name, and everybody in the whole world has to give it the same name, or else we won't know when we're Skyping with other chemists what they're talking about. Like if one chemist calls this Larry and another one calls it Ted, then nobody's going to know what the compound really is. And it'd be fun to name things like Larry or Ted or Mo, but we can't because IUPAC has decided we're not going to name things that way. So we got to follow what IUPAC says. So here's what IUPAC says. I want you to remember this. Number dash branch parent. That's the pattern that we're going to use. Number dash branch parent. Okay, number dash branch parent. Now, let's go with this. Find and name the parent, which is the longest continuous chain. So watch this. We just start counting. 1, 2, 3, 4, 5, 6. Okay, there's 6. 1, 2, 3, 4, 5. Okay, there's 5. 1, 2, 3, 4, 5, 6. Looks like the longest chain we could get is 6. So I'm going to just circle that. 6. I could have circled it this way, but we'll deal with that a little later. Okay. So that's the parent. Now we got to name the parent. How many carbons in that parent? 1, 2, 3, 4, 5, 6. 6 carbons, single bonds. All right, that's hexane. Okay, so now I know what the parent is. The parent's name is hexane. Now I got to find the branch names, and there's numbers associated with it. The next thing we do is we number the carbon atoms, giving branches the lowest possible numbers. Okay, so watch. That's carbon number 1 on the parent. So I'm going to number that 1. I'm going to number that one 2, and then 3, 4, 5, 6. So I've numbered all the carbons on the parent. And when I did that, I came up with the lowest possible number. This branch is attached to carbon 2. This branch is attached to carbon 3. It could have gone this way. I could have numbered it this way. 1, 2, 3, 4, 5, 6. I could number it right to left or left to right. Now, this branch is either attached to carbon 2 or carbon 5. This branch is either attached to carbon 3 or carbon 4. Well, the rule is go with the lowest possible numbers. So we're going to go with those numbers. Now let's name the branches. Name the branches and assign numbers. Okay. So here's a branch. Now it's got 1 carbon in it. You guys now know that a 1 carbon is a meth. And it's a branch, so it has to be YL, methyl. And this branch is attached to carbon number 2. So that branch is 2-methyl. Let's go to this branch. That branch has 2 carbons in it. Carbon 1, carbon 2. That is called ethyl, and it's attached to carbon number 3. So that's 3-ethyl. All right. Now we name the molecule using the pattern number dash branch parent. Now dashes go between numbers and words, and a dash goes between numbers and words, yeah. A comma goes between numbers, okay. And also we name these alphabetically. So this has to go first. E comes before M in the alphabet. So I got to put 3-ethyl over here, and then 2-methyl next to it. So watch. Here's the name. Alphabetically, I have 3-ethyl 2-methyl hexane. Now I kind of prefer Larry, but I don't get to make those rules. So 3-ethyl 2-methyl hexane. All right, so there you go. Now, let's talk about these things called alkanes. Okay, this is the first family of compounds we're going to talk about. Alkanes. So today's lesson is all about alkanes. Alkanes have the formula CnH to the 2n plus 2. Now, what does that mean? Well, it's really actually very simple. You know that this is ethane. There's 2 carbons, and there's 6 H's around it. Okay? Now in this little formula up here, N equals the number of carbons. How many carbons? 1, 2. So N is 2. That's how many carbons there are. So look at Cn. C2, H to the 2n plus 2. So 2 times n, which is 2. So 2 times 2 is 4, plus 2 is 6. So C2H6. Now you might say to yourself, wait a minute, I can just count that. C2, 1, 2, 3, 4, 5, 6, C2H6. Nevertheless, there it is. Cn, H to the 2n plus 2. So all alkanes have that formula. Okay? All alkanes contain single bonds only. So here's an alkane. It's butane. It's single bonds. Okay? That's how we know it's an alkane. Single bonds. And we call these molecules saturated. What does saturated mean? It means each carbon is surrounded by 4 single bonds. Okay? So this carbon has 1, 2, 3, 4. This carbon has 1, 2, 3, 4. Yeah, this one's shared, but around each carbon there are 4 bonds. Okay, now isomers. An isomer is a molecule with the same formula but a different structure. Okay, so watch this. This molecule here, butane, is C4H10. Now watch this. Here's another butane. Now it says here, to identify isomers, draw the simplest parent possible, then break off a carbon and make it a branch. Move that branch around, break off another carbon, make it a second branch, move that branch around. Okay, so watch. I can make an isomer by breaking off an end carbon, and I can place it in the middle. I gotta put a little extra dash in there because all carbons have to have 4 dashes. Now look at that molecule. Let's count it. 1, 2, 3, 4. How many H's? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is C4H10. These two are isomers. They have the same formula, but they have a different structure. And as soon as you change the shape of a molecule, the structure, you change its characteristics. It's kind of like, you know, you have twins in a family. This one might have, if they're not identical twins, this one might have blue eyes. This one might have brown eyes. Okay, they're twins. They're same formula, but they just look a little bit different. Okay. All right, and in chemicals, like this will have a different boiling point than this because it's structured differently. All right. Now, be careful about doing this. See what I did there? If you break the carbon off the end and put it up there, it's actually the same as this. These two are no different. We just took the C and bent it up. Okay? Now, these are not isomers. These are both C4H10 butanes. They're exactly the same shape. On paper, it looks like they're not the same shape, but three-dimensionally, they actually are. There's no change here. So, you can only put these carbons that you take off the end in the middle. Okay, in the middle. Carbon on an end is not a branch. All right, good. Let's keep going. So, name the following. Let's start with this one. How would you name that? Well, if you want to try this, we'll just hit pause. Okay, now, here's the name. Let's see if you got it right. It's 2-methylpentane. Why is it that? Well, you got to find the longest continuous chain. Find the parent. There it is. There's the parent. And then this is a branch. So in the parent, there are 5 carbons. 1, 2, 3, 4, 5. So the parent is pentane. This branch is meth, 1, ul as a branch, and it's attached to carbon number 2. 2-methylpentane. We wouldn't number it this way, 1, 2, 3, 4, and have 4-methylpentane. Branches should have the lowest possible numbers. Let's try this one. If you want to try it yourself, we'll just hit pause. Here's the answer. This one is 3-ethylpentane. Here's why. Parent, branch. Parent has 5, branch has 2. It's attached to the 3rd carbon. 3-ethylpentane. Okay, let's try this one. Alright, now this one's a little trickier. You'll have to take some time, so you better hit pause here. But let's see what the answer is. The answer is 3-ethyl 2,5-dimethylheptane. Okay, so this is a really tricky one. Watch this. Where's the parent? Okay, there's the parent. 1, 2, 3, 4, 5, 6, 7. You could have also gone this way. It'd give you the same answer. 1, 2, 3, 4, 5, 6, 7. Good. And these are branches here. Oh, and I numbered it that way. 1, 2, 3, 4. Because if I numbered it over here, 1, 2, my first branch would be a 3. Here, my first branch is a 2. Anyway, there's your numbering. There's your branches. Now this branch is the same as this branch. Those are methyls. This has 2. That's an ethyl. This one's attached to carbon 2. This one's attached to carbon 5. This one's attached to carbon 3. Now we name it alphabetically, so this one goes first. E comes before M. 3-ethyl, and then 2,5-dimethyl. Now, I gotta put the di in there. Remember, I've got the prefix methyl, and I got another prefix, dimethyl. So a prefix before a prefix. Yeah, don't tell Mr. Henniger that. All right, now, 2 prefixes, so dimethyl, and then the parent heptane. Great. Okay, let's go to this one. What would you name this one? Notice, this is called a structural diagram. This is a condensed structural diagram. And this is a line diagram. Each point on the line represents a carbon. So what's the name of that? If you don't want me to put it up yet, hit pause. Here comes the answer. Oh, dimethyl. Yeah, dimethyl, yeah, back down there. Okay. 2-methylpropane. Why? Well, if I was to draw this with a structural diagram, this is what it looks like. 3 carbons here. Each point's a carbon. 1, 2, 3. Okay, so parent, parent. And then this is a branch, and this is a branch. Branch, branch. So this is 1, 2, 3, propane with a methyl branch on carbon number 2. 2-methylpropane. Great. Okay, well, now we're at the bottom of the page, and you're about ready to do your assignment. This is a quick little assignment, a pre-assignment before the big assignment. I want you to draw 3-ethylhexane, doing a structural diagram, a condensed structural diagram, and a line diagram. Alright, so I want you to draw those 3. Okay? Then after you've done those, try this one. Ooh. Okay, good. Good? Yeah. Okay, guys, we're going to draw 3-ethylhexane. We're going to do this 3 ways. So here's the structural diagram. So I got to draw my parent first. 6 carbons. 6. Put the dashes around. And then on carbon number 3, carbon 1, 2, 3, I've got an ethyl. So that's what that one looks like. Okay, and now I can do a condensed structural diagram, which is like this. CH3, C with 3 H's, then CH2, and then C with just 1 H, then CH2, CH2, CH3. CH2, CH3, and then coming off of carbon number 3, I have my ethyl, which is a CH2 and a CH3. 2 H's, 3 H's. And then the trickiest one is the line diagram, and maybe I'll do it down here. So I got to count 6 carbons. 1, so that's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That's my hexane. And now off of carbon 3, I have an ethyl branch. I'm not worried about the angles, but we do it something like that. Okay, so that's 3 ways to do 3-ethylhexane. Okay, there you go.